Hello, my name is Mr. Fontenot. Welcome to my YouTube channel, Mr. Fontenot 1111. In this video, I'm going to be working problem number 1 from the Chapter 6 math handout. The first thing we need to do is get our notebook page set up. The top half of the page is going to be for redrawing our circuits and writing down our steps that we take to solve the circuit. And on the bottom half is our spreadsheet. We're going to be taking our known values from the Chapter 6 math handout. So right now we're working on number 1. So we're going to have a total voltage of 15 volts. And here you can see our resistor values. So you can see on this circuit I filled in my total voltage and I have filled in all my resistor values. Now since this is a basic combination circuit, and we know it's a basic combination because we're given our total voltage and all of our resistances, our first step is going to be to find RT. And the best way to do that is by redrawing our circuit. So we're going to look at our circuit here and we're going to see what is in series and what is in parallel. So if we look at R1 and R2, we can see that they're in series with each other and that there's only one pathway for current to flow through in that portion of our circuit. And we can see for R3 and R4, they're in series with each other and there's more than one pathway for current to flow through in this part of our circuit. So my first redraw, I'm going to have 2 resistors in series. This first value up here of 900 ohms comes from adding R1 and R2 together. 220 ohms plus 680 ohms gives me 900 ohms because resistance adds up in series. My second value here of 600 ohms comes from reciprocating the value of R3 and R4. Notice that this value here is not 2.5k ohms. I did not add these 2 resistors together to get this value. I reciprocated them. So it's 1 over under, 1 over under, 1 times 10 to the third, scroll over, plus 1 over under, 1.5 times 10 to the third. It equals, and the value is 600 ohms. The good thing about redrawing is it gives me somewhere to write down this value because I don't have anywhere to put that value in my spreadsheet area down here. So when I redraw, it gives me a place to put this value, gives me a place to put this value. So now that I can see that I had 900 ohms in series with 600 ohms, what do we do with resistors in series? We add them together. So this gives me a total resistance of 1.5k ohms. All right, so now that I have found my total resistance, in this instance, I'm going to save power till last. And if I can get 2 out of 3, I can solve for the third using Ohm's law. So I now see that I can solve for IT. IT would be equal to VT divided by RT. So I take my 15 volts divided by my 1.5k ohms, and this gives me a total current of 10 milliamps. So my second step here is I found my total current using Ohm's law. Now my next step is not really a calculation, it's just understanding how current flows through the circuit. So if I look at how current is going to flow through this circuit, from point A to point B is going to be the full 10 milliamps, the total current. And from point E to point F is going to be the full 10 milliamps. So any resistor that is on the main branch, its current will be the full total current value, which in this case is 10 milliamps. So my next step is I understand that I1 and I2 both equal IT because of their location on the main branch right here. So now I can fill in I1 and I can fill in I2 because they were on the main branch, therefore they do have the full 10 milliamps. Alright, so now I've got 2 out of 3 for V1, so I can take the 10 milliamps times the 220 ohms, 10 times 10 to the negative third times 220, and this will give me the voltage, 2.2 volts, dropped at V1. Next, I can take and multiply 10 milliamps times 680 ohms to find the value of V2. So I've already got the 10 milliamps in my calculator here. I just scroll over and get rid of the 220 and I put in 680, and this tells me that 6.8 volts is the value of V2. So my fourth step here is I found V1 and V2 using Ohm's law. Alright, now my next step, I need to understand that V3 and V4 will be the same amount, but they're not going to be the full 15 volts. If this was a simple parallel circuit, if I had a VT of 15 volts, I'd have 15 volts here and 15 volts here. But since it's not a simple parallel circuit, I have to take some other things into consideration. And this is the equation that I would use in this instance. V3 and V4 will be equal, but they're not going to be the total voltage. I have to take my total voltage and subtract from it the voltage I dropped at V1 and the voltage I dropped at V2. So if I take my 15 volts minus, open parentheses, 2.2 plus 6.8, it gives me a value of 6 volts. So V3 and V4 will both be 6 volts. They will be equal. The voltage will be the same for both of them, but it won't be the full 15 volts because of the voltage I dropped at V1 and V2. Alright, so now I've got 2 out of 3. I can solve for I3. 6 volts divided by 1K ohm gives me 6 milliamps. Now I can go ahead and think about this and figure out how much my I4 should be before I even do any calculations, because if I have 10 milliamps flowing from here to here, that would be these numbers, and here to here. And I just calculated that I have 6 milliamps flowing up this first branch, like this. Then how much current must be left over to go this way? If I had 10 coming in and 6 went this way, it's got to be 4 milliamps. But let me verify that. So I say 6 volts divided by 1.5 k ohms gives me 4 milliamps. 4 milliamps. So 10 milliamps comes in, 6 milliamps goes this way, 4 milliamps goes this way. It all comes back together at point E, and 10 milliamps flows from E to F. So that was my 6th step. I found I3 and I4 using Ohm's law. So the only thing left is all of my power formulas, and we can find those by using our basic power formula. PT is going to be equal to IT times VT. So I take my 10 milliamps, that's my I, times my V of 15 volts, and that gives me 150 milliamps. I'm sorry, 150 milliwatts for my total power. Now I can find P1 by multiplying I1 times V1. So I take 10 milliamps, I get rid of the 15 volts, multiply it times 2.2 volts, and this gives me the value of P1. I can find the value of P2 by multiplying my 10 milliamps times my 6.8 volts. I've already got 10 milliamps in there, so I just change the 2.2 to a 6.8. In engineering, 68 milliwatts. All right, for my next one, I'm looking for P3. So I'll multiply I3 times V3. So 6 times 10 to the negative 3, 6 milliamps, times 6 volts, gives me 36 milliwatts. Then for my P4, I multiply I4 times V4. So I'm going to change this 4 times 10 to the negative third, 4 milliamps, times 6 volts. And this gives me 24 milliwatts. And I can check my work by adding them all together. Now, since I know that they're all milliwatts, I can just say 22 plus 68 plus 36 plus 24 gives me 150, and I know that to be milliwatts. Thank you.